Hello, this is video is called Project Circuit Design. Um, this is a set of videos that will help you get started on designing the circuits you need for your project. At this stage, you have completed a block diagram of your system. You probably have something like this. At best, you might have 4 or 5 steps to your block diagram. I'll add one more over here. And you have probably drew some arrows to represent signals. That progress through the system. This could probably be some type of temperature sensor, and then maybe there are some signal conditioning, and you might have some type of processor or controller. Then you probably would have a driver of some type, and then you would have the last thing which you're trying to operate, which is the load. This is a basic digital system. And you designed this with the assistance of your mentor, and you came up with your own ideas as to what your application would be. But now you're wondering what to do next. There are many strategies depending upon your experience. One strategy that might be useful is to start off with the load and work your way back to the controller. So I have 3 steps. First, I talk about loads, and then secondly, I talk about load circuits, and then third, I talk about microcontroller load circuits. So let's start off with loads. One type of load that's very common in control systems is an LED. This is the symbol for the LED. And normally an LED comes in different colors, and it has 2 terminals, one called an anode and a cathode. We typically call it plus and minus. And it gives off a certain amount of light depending upon how much current flows through the LED. The symbol represented by the LED looks like this. It has the shape of a triangle, which represents a diode, and it is labeled as anode and cathode. But usually we know that this side is the anode, so we don't have to label it all the time. But I like to label it because I like to be complete in my symbols. Now, if I want to use this, we like to say to make it work. I mean, what does an LED do? Well, it creates light. That's what an LED does. It creates light. Now, it also does other things too. I mean, I can use an LED to hold a book open. I can use an LED to stick someone, like a pen. I mean, there are other things I can do with this object, but as an electrical engineer, I basically use this to create lights. And usually that light represents the status of something. to tell me something. I might use it to tell me when something is on or off, like the power. I might use it to flash when I'm transmitting information from one location to another. Or I might use its optical characteristics to actually send information to one place or another. So when you're talking about loads, you should think about what its purpose is. You should think about what the picture looks like, what the symbol looks like in the electrical drawings, what it does, and what is its purpose. You should be able to answer these questions. Now, if we're going to use this in an actual electronic system, there's something else that we have to know, and we have to know its electrical characteristics. And as electronics engineer, you know the 4 basic electrical characteristics include voltage, current, power, and definitely for AC would be frequency. These are basic electrical characteristics that we know to help us understand what we need to operate this device. It needs energy, and we usually apply that energy across the wire or the terminals, and that energy produces an action called current. So the energy source would be a voltage, and that voltage will create an action called current. And we have to be sure that we apply the right energy to produce the correct current to allow the device to operate, to do its job, which is to create light. So to summarize, loads are electronic components that we use to do a particular function. We start off by knowing what the load looks like and its connections. Secondly, we try to search for some type of symbol to represent the load in drawings, because we don't want to draw the load component all the time. Then we think about, well, what does this load do? It creates light. In our example here, this LED creates light. It's called a light emitting diode. And then how is it used in electronic systems? Well, most of the time we use it to indicate the status of something, to tell me whether something's on or off, like the power, or when the device is actually doing something. And we usually make the LED flash to let us know that something's happening. For example, when you're transmitting or receiving information. We also can use its optical characteristics to transmit wirelessly information. Last but not least, we need to know its electrical characteristics. What type of voltage is needed, which basically means how much energy is needed to activate it, and what current is necessary during that activation. What current is flowing through the component, as we say, when you apply the correct voltage or apply the correct energy across its wires. You get that from something called a data sheet. This is why I encourage everyone in the group to get and create a customized data sheet for all their components so they can be prepared to create their final circuit design or their circuit solution. In the next video, I will talk about creating a circuit to operate this component.